Hi everyone, and welcome back to another video of the series API testing using Postman. In today's session, we will discuss types of API. When you are working on a project, it's important to understand which type of APIs will work best for you, and it's based on several factors. In order to achieve effective API performance, it's critical to identify the optimal type of API for your business. So few of the examples we will discuss over here are their intended use case, who will be accessing these APIs, the systems or datasets that need to be connected. So many organizations, they start with an idea or a use case that requires connectivity to some other systems or datasets. This is how the need of APIs originate as a mean of enabling connectivity between the systems and datasets. Or it can be documentation as well. So regardless of how good your API is, if developers doesn't know how to work with it, it will be just an unusable piece of code. So API documentation is a kind of reference manual with all needed information about the API, including its functions, arguments, or classes, etc. Let's have a look at the APIs by use case. So intended use case can be database APIs, which enable communication between an application and a database management system, or they can be operating system APIs, defines how applications use the resources and services of operating systems, or they can be web APIs, which are the widely used kind of APIs, and this is what we will be discussing a lot in this series. So Web API is an API over the web which can be accessed using HTTP Hypertext Transfer Protocol, which means that through this protocol, the exchange of data or information can occur between desktop, web applications, mobile, etc. Web APIs are enhanced form of the web applications to provide services on different devices like mobiles, laptops, etc. Okay, so why do we need this? Because nowadays everyone is using different browsers and different devices in their daily life. So in order to expose your data to all of these browsers and these devices, we need to have a compatible API. Developers can use web APIs to extend the functionality of their applications. For example, Google Maps API. So Google Map API, it allows developer to retrieve data from Google Maps or embed Google Maps on their website, etc. Further divided into client and server based on how they extend their functionality. Okay, let's have a look at it now. So client-side APIs are interpreted by the browsers, while server-side APIs executes the code on the server before it is sent to the browser. So the server-side portion of the web API is a kind of programming interface to a request-response messaging system, which is typically referred as the web service. So now as we are talking about web service, I would also like to briefly discuss about a topic which is usually confused, which is the difference between API and web service. So if we talk about web APIs and web services, these are overlapping terms, but not exactly the same. So the common thing is that both serves as mean of communication, but the difference is that web service always require a network, while APIs, they do not have any such requirement. So we can say that all web services are APIs, but all APIs are not web services. So I hope that this is clear, because this is a very common question usually which comes in the interviews. Okay, so this is the same image which we discussed in the last session as well. So if we take again an example of an application known as My App. So what's happening over here is that Web API takes requests from different type of client devices like laptop, mobile, etc., and then sends them to the web server to process it and returns the desired data to the client. So over here we are using different web APIs which are like Facebook, Google Maps, and PayPal, and then they are returning all the desired data to the client. Okay, let's discuss about now API's access. So once you have selected the intended use case for your organization's APIs, now is the time to decide that who will be accessing these APIs. Most often the use case and the intended user go hand in hand. For example, you may want to integrate any two internal systems in your organization. So over here, the intended user will be the internal employees. There are 4 types of APIs based on how they are managed and who they are accessed by. The first one is external, which is also known as public APIs. These are available for any third-party developers, and further in external or public APIs there are 2 types which are known as open and commercial. So the open API are in which all features are public and can be used without any restrictions. It just has to be accompanied by clear documentation so that the developers who are using, they know that how to use that API. While commercial API, they are public but commercial, which means that they are not free to use, but normally they have either a subscription fee or pay-as-you-go model. So some commercial APIs, they also offer free trial for a limited time before moving to a paid plan. The next one is internal, which is also known as private APIs. These are designed for internal use within an organization, and these can enhance an organization's productivity. So internal APIs, we can assume like a database of internal assets which can be used by other projects and can reduce the development time and resources, and it can also enhance productivity and efficiency. The third one is partner APIs. These are not available to public. They need specific licenses to access, and these are paid for service. So the concept of partner API is similar to open APIs, but access is restricted to specific business partners who have signed an agreement. These APIs are usually intended for specific purposes. So a common use of partner APIs is when two organizations, they want to share data with each other. For example, if we think of an hospital and a blood bank, so this would be a great example of a partner API. In this case, a partner API would be set up between these two organizations, which has access to the necessary data with the right set of permissions. The last one is composite APIs. So composite APIs combines different data and services APIs. It's useful in microservices architecture, which means that where you need information from several services to perform a single task. So I hope that you already have an idea of what is the difference between a microservice and a monolithic architecture. If not, then I will just briefly touch base that area as well. So a monolithic architecture is basically built on one large system, and it's usually have only one code base, while a microservice architecture is where an application is built as a set of small services, and each of these services has its own code base. Okay, so coming back to the composite APIs, the last one is developers can access multiple endpoints in one call. Okay, so these are the 4 types. So some companies, they may start with partner APIs and then decide to make it public or even revert it to private. Okay, API architectures and protocols. So another consideration is which architectural style or protocol needs to be used. An API protocol defines the rules for API calls. For example, it specifies accepted data types and commands, while different API architectures, they specify different protocol constraints. So the API architecture or protocol, whatever you are using, it's very important to select a style which is supporting the intended use of the API. So a basic understanding of existing infrastructure is also necessary before making any kind of decision. For example, whether the systems are cloud-based or on-premise, or which security protocols need to be implemented, or what kind of functionality would be needed, etc. So there are various styles of architecture and protocols for APIs. We will be discussing some of the most common ones, which are RPC, SOAP, and REST. Okay, let's have a look at RPC. RPC stands for Remote Procedure Call. This is the architectural style for distributed systems. Requires developers to execute code on another system. Most widely used RPC styles are XML RPC. Data is formatted in XML, and the other one is JSON RPC, RPC API coded in JSON. Tightly coupled, which makes it harder to maintain or update. All right, okay, so the central concept in RPC is the procedure. So the procedures do not need to run on the local machine, but they can run on a remote machine within the distributed system. For example, we can take an example of remote error logging. Okay, so RPC APIs are very easy and very simple to develop, but because they are tightly coupled, it makes it difficult to maintain or update. For example, if there is any kind of change required, then the developer need to go through various RPC documentation to understand how one change can affect other. And this is why, and of course this is widely used only in distributed systems, and that's why there was a need of another kind, which is SOAP. SOAP stands for Simple Object Access Protocol. XML-based communication protocol, language, transport, and platform independent, standardized by W3C, most widely used protocol for web services, mostly for internal use or for services called by trusted partners. Message format is defined through WSDL, Web Service Description Language file. Okay, so when we talk about SOAP, it's an official protocol, and as we have seen that it's standardized by W3C, which stands for World Wide Web Consortium, and it has strict security rules. And SOAP is basically preferred when there is a desire of to achieve a high level of security. But because of these added security requirements, it makes SOAP quite complex and very resource intensive. When we talk about WSDL, it defines the elements which are allowed in the message exchanges. So it is machine readable, and it's used by the servers interacting with each other to facilitate the communication. Okay, so this diagram will help us understand more how SOAP works. So if we have a look, we have a service requester, and then we have a service provider as well. And there are SOAP messages exchanged using either HTTP, SMTP, or any other transport, because we just learned that it's transport independent or platform independent. And if we have a look over here, it converts procedures calls to from XML messages. So it uses XML as an encoding scheme for request response parameters using any means of transport. So main problem with SOAP services is that XML message format is too heavy, which slows down the processing times. So it's still used in enterprise application scenarios with the server to server communication, but now it is widely replaced by REST, especially for APIs on the open web. So let's have a look at now REST APIs. So REST stands for Representational State Transfer. And the biggest difference between REST and the others are that it's not a protocol, it's an architectural style for services. And why it's an architectural style? Only because it is not dependent on a specific protocol. It requires use of HTTP, can use any message format including XML, JSON, CSV, HTML, and many more. It's a service which complies with REST constraints is known as RESTful. So any service which complies with the constraints defined by REST is known as RESTful. Okay, so REST is considered a relatively user-friendly API to work with. It specifies how data is presented to a client in a format that is convenient to the client. So when building a system with minimal security considerations but strong speed requirements, then REST is an excellent choice. So it defines a set of architectural constraints and agreements. For an API to be RESTful, it needs to follow certain rules, which are as follows. The first one is stateless, like stateless in nature. REST APIs, they do not allow the server to retain the information they receive from the client. The client sends information to the server in packets that the server can understand in isolation. That is, that without context from the past packets. Second one is client-server architecture. Client and server needs to be independent of each other. In other words, the changes which we make on the server shouldn't affect the client and vice versa. This architecture enables each side to grow and scale on its own without affecting the other. The third one is cache. Client should be able to cache the responses. The client side of REST API should have the ability to cache or store information for a certain period of time. This reduces the number of times the application needs to call on the API, and in turn it reduces the server usage and it also saves resources. Fourth one is a layered system. API should support a layered architecture. Okay, so it should support a layered architecture and each one contributing towards a clear hierarchy. So each layer is loosely coupled, which makes RESTful architecture so scalable that multiple layers are then used to grow and expand the interface. This also allows for new commands and middleware to be added without impacting the original commands and functioning between client and server. And the last one is uniform interface, which is it prohibits the use of multiple self-contained interfaces within an API. So as the name suggests, the interface should be uniform. And when we talk about a REST API, it's basically based on these three. It's like kind of a triangle which has these three components: nouns, which is like identifies resources, like URI. So URI is uniform resource identifier, which is a string of characters that identifies a particular resource. Or there are verbs, which are standard HTTP methods like get, post, put, delete. And the content types, which is like HTML, XML, JSON, etc. So we will be discussing this a lot in detail because we will be mostly using REST APIs with Postman. So we will get to know all this more in detail. All right, so the last one is SOAP versus REST. All right, so first of all, we can't compare SOAP or REST APIs because uh, the basic structure is different. We know that SOAP is a protocol and REST is an architectural style. But still, it would be beneficial to know that what are the key differences between SOAP and REST. So we are not saying that which one is better than the other, because now we know that the intended use for both of them is totally different. So it all depends that what kind of architecture style or protocol a company needs. So a SOAP uses only XML, while REST allows many data formats, including XML, HTML, JSON, etc. SOAP requires more bandwidth and resources because of the XML. It makes it quite heavy, while REST requires less bandwidth and less resources. SOAP cannot be cached, REST can be cached. SOAP defines standards to be strictly followed because it is a standardized protocol, while there are no defined standards in REST like SOAP. SOAP is language platform and transport independent, while REST requires the usage of HTTP. In SOAP, WSDL defines the endpoints exposed by the service, while in REST, it uses XML or JSON to send and retrieve data. SOAP has built-in error handling system, but there is no error handling in REST. There's no built-in error handling in REST. SOAP uses services interface to expose the business logic, while REST use URI to expose business logic. SOAP supports stateless and stateful operations, while one of the principles of REST is stateless communication. SOAP invokes services by calling RPC methods, while REST simply calls services using HTTP request. So I hope you found this video useful. In next video, we will be discussing why API testing is important. So I hope that you will join me in the next video as well. Till then, take care.